these are the two types of errors that we can make when drawing a conclusion during a hypothesis test. And we kind of saw the first type 1 error here in the case before when we were sending an innocent man to jail. So this is the mistake of rejecting the null hypothesis when it's actually true. And the symbol alpha here represents the probability of this occurring. We'll use this symbol later on to also indicate the significance level that we're using to draw our conclusion. And so in a sense, this probability of making an error making a type 1 error will be the same thing that we're using for the significance level of a hypothesis test. The type 2 error is the mistake of failing to reject the null hypothesis when it's actually false. So in the previous example, this would have been when we claimed a guilty person to be not guilty. And so we'll use the symbol beta for this type of error. So let's think in this kind of example here, on average it used to take 30 minutes to find parking, but we think we may have sufficient evidence to say that the time has decreased. In fact, however, the true parking time is still 30 minutes, so it hasn't changed. So even though we have evidence to say that the time has decreased, we made an error, and so the parking time really hasn't changed. And in this case, the error that we made was where, in this case, we would have said our null hypothesis was that mu equals to 30, and our alternative hypothesis would be that mu has decreased. It's less than 30. And since in this case, we rejected the null hypothesis and said that our evidence supports the alternative, but in fact, the null hypothesis was true. So in this case, we made an error because we rejected the null hypothesis when it's actually true. And if you look above, this would be a type 1 error, where we're making the mistake of rejecting the null hypothesis when it is actually true. So this is a type 1 error. And one thing that we're going to use in the future is when we make a claim about the majority. The majority is a number or percentage equaling to more than 50%, right? So anything more than 50%, we would say that's the majority. So in other words, more than half. So to test a claim about a majority, usually we're going to use a proportion that's equal to 0.50 for the null hypothesis. In this example, a Gallup survey reports that 57% of 504 randomly selected gun owners support stricter gun laws. Test the claim that a majority of gun owners favor stricter gun laws. So what we'll do here is we'll just write out the hypotheses for this example and think about what a type 2 error would be in this scenario. So we're not going to go all the way through the test, but just think about what a type error would be in this case. So our null hypothesis is using the claim that a majority of gun owners favor stricter gun laws. So our null hypothesis will be that a majority favor stricter gun laws, which means that the proportion of people that support gun laws, the proportion of people who favor stricter gun laws is greater than 50%. So really, the claim that we're making here comes from the statement that the proportion of people is greater than 50%, because that's the majority. more than 50%. Our null hypothesis will be equal to 0.50, right? Because our null hypothesis should always involve the equal symbol. But this here, our alternative hypothesis, is really the symbolic form of our original claim. And so the type 2 error that we could possibly make here would be the error of failing to reject the null hypothesis when it's actually false. So, type 2 error is failing to reject the null hypothesis when it's actually false. So let's think about that in the context of this. If we were to fail to reject the null hypothesis, then we would not have enough evidence to support our original claim that the majority of gun owners favor stricter gun laws. So in this case, the type of error that we would make is that we would say that the evidence doesn't support that claim when in fact that claim is true. So we would be making the error of saying the evidence doesn't support the claim that the majority of gun owners favor stricter gun laws when in fact they do. And in this case, maybe this kind of error is not as grave as the other kind of error, depending on the scenario here. But here, it doesn't seem like the consequences of making this kind of error would be that bad, other than maybe it could, for instance, be used for political reasons. Maybe a politician can then use this argument to draft policy or to draft different laws. But the consequences may be not as grave as other cases.